Hi everyone, my name is JB of Sela Network. At Sela, we're building the new data layer of the internet, a decentralized network that unlocks high-quality ungated web data for AI, finance, and data-driven businesses. What we're trying to solve is that today's data infrastructure presents several challenges. Scraping APIs are expensive, fragile, and often blocked, and centralized providers create single points of failure. Also, AI systems are unable to access real-time web reliably. These issues result in outdated models, missed opportunities, and high data cost. Our target clients are businesses that are data dependent, such as AI startups that need real-time and structured datasets, DeFi protocols, and trading firms that rely on accurate and updated financial data, and also market research companies that need access to gated content at scale. So now let me show you how Sela works in practice. So this is the Sela Node app. First, you turn on the Sela node, and it is connected. This registers your device on the network and connects it to the pool of active data fetchers. On the dashboard, you can see the node status, the points earned, today, and the points of total. Based on our point system is based on the uptime and the tasks that are being operated or being completed by the node. And you can also see the reward history. On the client side, if you are a data-dependent businesses, this is the data consumer dashboard that they can come in and try out our API. This is the home where this tracks the API usage. And if you go to Playground, this is where you can the clients can test their scraping needs. So now let's try to do a scraping for a Twitter website. As you can see, these are the real-time live scrape data from the node. As you can see, you can check the content and the image and like count, post today, reply count, retweet count, tweet ID. You can also check in different, you can also increase and decrease the amount of the post or reply counts as you wish to do. The structured data is returned here in the app. So basically business and the developers can plug directly into their AI models, trading system, or dashboards using our API. And for those, each node that contribute to scraping gets rewarded with Sela points as reflected on the dashboard in real time. These points are convertible into further benefits in the ecosystem. Now our dev team will go through a walkthrough of our technical overview. Please enjoy.
This is the overall walkthrough of the tech stack that is being used in Sela Network. So our application is basically the latest version of Node running on TypeScript. So we have built a hybrid server, which is basically serving the WebSockets as well as the HTTP endpoints. We are using combination of both, and therefore we have made a hybrid server for us. For database part, we are using Redis, and we have a persistent storage. Therefore, we are storing each and every single thing in our Redis database for fetching it fast and accurately. And you can see the basic setup of our application. We have set up the Express application using Node and TypeScript, and set up our different services which we are using in terms of reward distribution, in terms of blockchain distribution, and the server itself. For the canister part, we have created our canister for using file storage and everything that is basically the result of the scrape results. So we have used it and indexed it and kept our data on our canister, which is basically can file storage built in Motoko. And it has all the functions that we need, which includes get file function to get the file, delete file if we want to get the info of the file, if we want to list files by job, or if we want to get the storage stats. So we have all of those functions built in, and a health function as well to check the health of our canister. So basically the hybrid server is broken into two parts. One is the WebSockets and one is the HTTP endpoints. For HTTP endpoints, we have structured our application in a different manner, and I'll walk you through the project structure as well. So here you could see that we have the source folder where we have all the APIs, And now we have broken down into file routes, node routes, reward routes, RPC routes, and utility functions, and a generic response that we are using for errors and successful. Other than that, we are using authentication, and for that we have the auth middleware present over here. Moving forward, this is the canister file, which includes the candidate server interface as well, written down in TypeScript. So this is the overall overview of an application, which is built on Node.js using Express, built-in TypeScript, utilizing Redis as a database, creating Motoko canister for file storage, and using the fallback strategy in case of file storage. We are storing files on server as well as on the canister as well. So we have a fallback strategy in place as well. So this is the overall technical demo.